Alright, today we're going to work on a repair job on a steam locomotive. This is a Vuclan Iron Works 040 steam locomotive built in 1917. And this is the main locomotive we use out here at the Georgia Museum of Agriculture. What you're looking at right here, this is the steam cylinder that is on the left side of the engine. So we got the cylinder down here that goes back and forth, and of course this connects to the drivers on the train. And above that, this is actually where the valve is, the steam valve. It lets the steam get into the engine. So as this thing moves forward, this valve rod is going to go back and forth. There's a slide valve in here, which you'll get to see in just a little bit. But there's a block of cast iron, kind of a head that goes between that valve and the main cylinder. And between that is a copper gasket. And in the last couple of months, we begin to notice that this copper gasket is starting to leak some steam. So today's job, we're going to basically pull this thing apart, and we're going to make and replace that copper gasket that goes in there, which will hopefully resolve the problem of our steam loop. All right, just to kind of show you what we got before we get started here, there's two things that we're going to take off to start with. The first, this is an oil line that comes in. We have a mechanical lubricator on here, so basically every time that valve rod goes back and forth, it kind of clicks a little plunger in a pump on an oil pump, and it pumps oil into these lines. And in the oil that we're using is steam cylinder oil. So just like in a regular gas engine, you have the oil pan in the bottom that lubricates the cylinder, the pistons and the cylinders. Well, in the case of a steam engine, we don't have the advantage of having that oil pan, so we actually have to inject oil to mix it in with the steam. So oil comes in here. There is a valve in here that we have that basically a check valve that will keep the steam from going back into the line, but the pressure from the pump will overcome that, and it will pump oil down in the top of the cylinder where it will atomize with steam, and then basically that will lubricate the valves in the cylinder. So we're going to just take this off and move it out of the way. Also on the front here, it's a little bit hard to see in the video, there's a little poppet valve here. This right here, basically when it's under pressure, there's a little valve in here, just like a valve in an engine, and when that pressure's on there, it pushes it up and basically closes that valve and keeps the steam pressurized in the cylinder. But when you're stopped at the station or wherever, and the pressure in the cylinder comes down, that valve will drop down, open that up, and just kind of let the steam breathe so that you don't build up pressure and the train can take off while you're sitting there and you're not wanting to go somewhere. So as soon as you put some pressure on that throttle, it pops that valve up, and everything's good. So we're going to go ahead and pull those off now. You ready? Get down there to that middle plate. So we can get this up. Okay, now we're getting down into the meat of things here. What we took off there was just a cast iron valve cover that just fits over this, and it just protects it. And this is basically the head, the cylinder head, I guess you would call it. And underneath this is the steam, the valve that's going to slide back and forth. So now that we got this all exposed, the next thing we're going to do is we're going to get a air wrench, and we're just going to pop off all these bolts holding these studs down that's holding this on, and then we can get in here and take a look at what's going on. All right, just giving you another view of what's going on here. So again, this is the valve rod that comes in, and basically on one of the driver wheels there's some eccentrics, kind of like cams, that are on there that will cause a very complicated mechanism here, the reversing gear, where you can actually put the engine in forward or reverse. But basically it causes this to rock back and forth, this valve to rock back and forth. It's also adjustable, so that depending on if you need a lot of pressure, or whether if you're on a main line, you're kind of underway, you just need a little bit of pressure. It will also adjust the stroke of this valve. So it can either be taking a real long stroke if you need a lot of power, or you can back it off once you get the train moving, where it's taking a short stroke. That's not using as much steam, but just keeping the engine going. So this is going to go back and forth, and that's going to go in right here into the steam cylinder head there, and that's going to move that valve back and forth. This is there. Let's see what's got here. All right, here's a close-up shot just showing the valve in this steam chest right here. So again, the rod's coming in from the back here, and this is actually the valve, and it just slides back and forth in this chest, and there's ports coming in for basically where the steam comes in and where the steam exhaust is and so forth. On top of here, you see there's some plates, there's some springs up underneath this, but the plate that we took off the top just now is just basically a flat surface, and these spring-loaded plates will just literally slide back and forth on that, and it'll keep some pressure on this valve and keep it pushed down real good and keep it sealed up. So anyway, the next thing we'll be doing here is we're actually going to be disconnecting this the valve part here from the rod, and then we'll pull the whole head off. Now, if you notice, I don't know if you can see this very well, but right around here, this is one of the copper gaskets, and this is the gasket that goes between the top of the head and that plate that's on top. There's also another copper gasket on the bottom of this head, and we're gonna, I think we've decided what we're gonna do is we're actually gonna replace both of these copper gaskets. So we'll take this off, we'll make a new gasket to go in there. They've both been compressed and used many times. The actual steam leak that we have is on this back side over here. We got down here and started looking, and you can actually see where the steam is pushing out between that gasket. So again, it's just where the gasket, probably the reason that happened is we've actually worked on this a couple of times over the last couple of years, and we've just continued using the same gaskets over and over again. And each time you torque this thing down, the copper gasket here will just compress a little bit more, and eventually you just need to replace it. So we're to that point, so we're going to go ahead and replace both these gaskets. Okay, the next thing we're going to do here, I'm just going to take a paint marker and I'm going to put on these little pieces in the valve here, which one goes, where they go. So this will be front left, this will be front right, this piece here will go in the front, this will go in the back. And as you can see, we pull these out. There's actually a little spring down in the bottom there that we'll pull out as well. We got a little screwdriver. There you go. Just a little spring. Actually, I got it. Thank you. Okay.
All right, Chandler, what you do is gotta, I don't know if you can get something there yet on both sides. What we gotta do is...
You want to start off really small?
Yeah,
Yeah.
whatever it takes to get it.
Alright, now that we got the actual head off, you can really start to see down here what that valve is doing. So that valve is basically sliding back and forth across this plate right here. You can see the wear marks where it goes around and around. And what you'll notice here is that there's some different holes in here. So what happens is the steam is coming from the boiler. It's actually coming up through this cast iron piece, and the steam is coming up through the center here. So the steam is coming up in here, and depending on which way the valve is, it actually has a place for it to go where it goes back down in this side or this side, and that's how the steam gets into the actual cylinder. So as it moves back and forth, it's going to open up one side or the other. Unlike a gasoline engine, a steam engine actually pushes on both sides of the stroke. So when the piston comes forward in here, it's going to open it up so that the steam will go into the front, and it will push the piston back. And when the piston gets back, it's going to open up this one so the steam goes to this side, and it will push it forward. So on each complete stroke of the cylinder, you're actually getting two pushing strokes, unlike a gas engine. A gas engine, well, on a 4-cycle engine, you're really only getting one push every 4 strokes, whereas this one you're getting one push, I guess, every 2 strokes, where on this one you're getting 2 pushes for every single stroke with the steam. There's also, you see where the water is here, this is actually the exhaust port, so that whenever that valve goes forward or starts to go back, it opens it up so that it will allow the steam to exhaust. The exhaust actually goes back out through the smokestack. It goes through the front of the boiler, which creates a draft, which pulls more air through the boiler, causes the boiler to burn hotter, and that will then exhaust through the smokestack with the gases coming out of the boiler. So we got this done. Next step here is we're just going to get this cleaned up. There's a lot of gunk and grime and oil in here from where she's been sitting. So we're going to get this cleaned up real good, and we're going to go start working on the head now. Okay, we've got the head in here now, sitting on the welding table in the shop, where we can have a little more room and start working on this thing. So again, now you can really see the action of this. You can actually see how this head in here, or the valve in here, it's so tight I can't do it by hand, but as that rod pushes back and forth, it's just going to move this back and forth. And again, you saw the holes in the actual cylinder over there, and that's going to let the steam go into the port where it needs to be, pushing on the cylinder at the same time opening up the exhaust on the other side so that it would work properly. So right here is one of the copper gaskets. There's one on the top and bottom. We're going to go ahead and pry that off, and then we're going to make some new gaskets and get this thing ready to go. We'll clean everything up in the process. Okay, you see the gasket here. This is actually just made out of copper wire. We're going to use, I think, number 2 copper ground wire, like an electrician would use to make this. There's actually a little slot milled all the way around this. This gasket fits down inside, so we'll have to make that gasket so that it'll fit down in here. And when we make the new one, of course, this has been flattened out from being used over and over again. When we make the new one, it'll be actually round. And that will give us a little bit more compression when we tighten up the bolts on this thing, where it will create a real good seal all the way around the piece. I'm going to flip this over now, and we'll get the bottom one done. Let me clean that up first. Alright, this is the actual valve, and you can see here it basically just has an opening in there, kind of circular at the top, so that steam is going to come out of the center and it'll go down into one of those ports on either side. And at the same time, there's enough coverage in here that it covers up the exhaust port on the opposite, or on the side that it's pushing on, and opens it up on the other when it goes out. We'll just set this over to the side. Alright, this is the bottom of the cylinder now.
And just clean this up a little bit. There we go. So 2 gaskets there, basically both the same. Maybe some slight differences between them. We'll make 2 new of those here very quickly. All right, we took this head over and put it in the parts washer and just kind of tried to clean up some of the oil and grime and grease and everything that was on there. As you can imagine, with that cylinder oil going down in there all the time, it just, particularly around the outside where you just get a little bit of steam leakage or whatever, it just builds up over time. So right now we're just, again, we got a little machine surface in here that this gasket fits into. And I'm just going to take a brass brush here and we're just going to clean that up real good, make sure that we got that good and flat all the way around. All right, now I think you can kind of see this a little bit better too. Here is the where the valve rod comes in, and you can see this yoke in here as that valve's going back and forth. It's just going to go back and forth, back and forth. And the head, right, or the valve right here that fits inside this yoke, it's just going to allow that steam to go into that chamber depending on where it's at. And like anything else, it has to be timed. It's a major chore to time a steam engine. We actually had to do that recently to this one. I will point out too, you know, working on these old equipment like this, there's hardly a part on this train that you can just run to the store and buy. Everything is pretty much, if it breaks or tears up, you just have to be creative and recreate it. And we have to do repairs and maintenance on this thing rather frequently and have to be kind of ingenious sometimes. Probably about a year or 2 ago, one of the repairs that we did was we actually replaced these valve rods. The ones that were on there, I don't know how old they were. I don't think they were original to the train. Probably had been put on there back in the early 80s when this locomotive was restored, when they brought it to the museum. But over the years, basically what's happening is inside this chamber right here, there's just some packing. Of course, this whole head will be pressurized at some point in time. So you got to keep that steam from pushing out. So there's just metal packing that goes around and around and around. This piece here, actually you see the bolts and studs, that tightens and pushes that packing in there. And as it wears out, we'll put more packing in there to keep it from coming out. Well, over time, it had literally worn the diameter of this rod down to where every time it was going back and forth, it was just dragging the packing back and forth. We couldn't get the steam was just coming around this really bad. And of course, when we pulled this off and looked at it, we realized we had to replace these. So, you know, we basically had to make them. I was able to get some hardened steel that was chrome plated. We cut it to length, turned the end down here. We threaded this on the lathe so that we could put the rod on there, or the connecting rods. This piece here, it was actually been welded to this yoke, and then it was pinned right here, so it was turned and went in there and welded. We had to come here with a grinder and grind out all the old weld, press that piece out, and put it in there and re-weld it all back up together. So it was a pretty major undertaking. I think that was the last time we had this head off, and evidently the copper gasket, we probably should have replaced it then. We tried reusing it one too many times, so that's going to be our job today, is to fix that. Alright, we've got the copper wire here that we're going to make the gasket out of. And again, this is just number 2 copper wire that we use in the electrical situation. But the first thing we're going to do before we start working on actually making the gasket is we're going to take this and anneal the copper. Copper is a non-ferrous metal, and one of its interesting properties is that as you work it, as you do things with it, it becomes hard and brittle. So even just rolling it through the dies, where they actually made the wire in the factory, it work hardened this piece. So we want to get it good and soft so that we can work with this and bend it around, get this good and straight. We got some pins in it. So just to make our life easier, we're going to anneal it. Now to anneal copper, unlike steel, it's almost the opposite. What you want to do is you want to heat it up red hot, and just that heating process will cause it to become soft again. You can quench it. Quenching is not absolutely necessary. The main thing is just heat it up red hot. And in the process of doing that, what happens is those copper molecules are just really tightly linked together as it becomes work hardened. But by heating it up, you just kind of spread them apart a little bit, and it makes it more malleable. So to do that, we could use the oxyacetylene torch over here. But copper does melt at a fairly low temperature, so I'm actually going to use a MAP gas torch. This gets hot enough to heat it up, but it doesn't get to actually melt the copper with this. You really have to work hard. Whereas with the oxyacetylene torch, in just a second, you go from having a good piece of copper to ruining it. So I'm just going to use this, and we're going to heat it up and anneal it. We had about 12 feet of copper wire to anneal then, so it took us about 20 minutes to get down the entire length of that with the torch, get it heated up red hot. But it is amazing now that we've got it, just how much easier this bends and moves. Not that bending copper wire is a hard thing to do, but that little bit of annealing, I mean, I can really get in here and fine tune this now, whereas before. Starting to get some rain, been storming a little bit earlier this morning, so I hope y'all can hear me over the sound outside as it's starting to rain. I'm going to start working around getting this gasket roughly formed to the shape.
I think that's Cody splitting wood.
Maybe.
I don't know.
That's pretty good.
Following you right along.
He's quite the cameraman.
Trying to be.
That's perfect. That is perfect.
How much you gonna just butt them together to weld them, or you gonna spark it?
I'm gonna probably scarf it.
I don't know what. I think he would take a brush and stick this in and brush whatever he brushes that. You think it's just what it says, so you can use something like that.
I'm just gonna.
You get another one? Another one for the next time?
Yeah.
I get it.
Cameraman up there? No. Let's go there. Right up there for this valve to go in. And then it's big. Grind and stuff. Build it up. That's my gasket later.
You seen us all copper gasket?
All right, we've got this copper gasket. I've still got a little forming to do on it, but before I get there, I want to go ahead and get it joined together, and then we'll work about getting it fitting just exactly right all the way around. So what we did was we put it together, and I've got a scarf joint here. I just went over to the grinder and just ground two mating scarves back to back. I've clamped these in place because it's real critical that this joint be just right. But if you look, the wire's actually coming up just a little bit off of this cast iron piece, so I don't have a heat sink up underneath it, so for when I weld this. And we're just going to basically use an oxyacetylene torch, heat it up, melt it, and use some copper filler rod just like you're brazing. We're just going to use copper as a filler there. If we get it just right, we may not even need the filler rod, but I'll have it there. I am going to put a little bit of flux on here. I've just got some copper bright. This is something that they use for soldering copper pipes together. It just keeps any oxidation off of it. So I'm just going to put some of that on there first. This is just a liquid. I got a little acid brush here, and we'll just put some all around here, and that will hopefully help us with the oxidation, make sure we don't have any problems. Okay. And with that, we'll heat the torch up and start putting this together. I've got a welding tip in here. I got the smallest one I could find because I really don't want a lot of heat. Copper melts at a relatively low temperature compared to, you know, aluminum or maybe not aluminum, but like steel or even brass for brazing. And if this thing gets too hot, it will basically just vaporize and be gone, and then we have to start over. So we're going to be real careful, try to keep our heat down relatively low. So I'm going to put as small a flame on here as I can to work with. All right, I think we got it. Just gonna let that cool now. Okay, we've let this sit up now. I actually cooled it off a little bit. And let me get in here a little bit closer. And you can see it's a little bit rough, but that's fine. We can always take off that excess material. But the point is we got a good solid fusion of this piece together. So I'm going to just take this over probably to the grinder and just kind of clean that up a little bit. And then we're going to anneal the whole piece again, and then I'm going to really fine tune getting all the little bends out of this and get it fitting down in that groove just right. All right, we have pretty much got this gasket ready to go now. After I annealed it, I just kind of took a file and cleaned this up a little bit. We've been hammering on it on the flat surface here, just make sure we got everything good and straight, just little light taps. One little thing, I didn't catch it on video, but we did notice that up here where we welded it, it looks like it had shrunk in just a little bit and it didn't quite fit in the grooves just fine. So to get around that, I just took a ball peen hammer laying on the flat table and just tapped it along the edges. I wanted to keep the top pretty much round, but the edges, you know, kind of like this, I went around there. And by just tapping it a little bit, it actually stretched that side out so that we got it to fit into the groove just right. So, you know, I'm pretty happy with what we got here right now. You know, it's not perfectly flat, but as when we put this back on the train and torque it down, it's going to basically squeeze and conform this gasket right in there, which is exactly what we want to. So I'm happy with this one. So now we got to flip this over and do the other side. We took the copper gasket that we made after we welded it up and went over to the grounder and just ground this down. Got it nice and smooth, and then once again we took the whole thing and annealed it one more time, make sure we had a good even soft copper all the way around. And that's going to be real critical when we put this back together. We really want this copper to be just as soft as we can, because even though there is a machine groove that this fits into, you can look at it and tell there's just a little bit of pitting and whatever in there for just the years that this locomotive's been in use. It's almost 100 years old. So by annealing that, the theory is that when you tighten it up, that basically this copper gasket's just going to conform to its mating surface, and you'll have a real nice finish. I will say a little bit about doing this. I'm not going to put on any airs at all. I am by no means an absolute expert on how to do this kind of stuff. There's very few people left in the world who are experts on working on steam locomotives. Most of them, unfortunately, are long gone. But there is still a good community of people out there working with other museums, working in hobbyists, not so much with locomotives, but in the steam traction engines and things like that. And it's a good lot of people. And I guess the longer you're in this, the more you get the opportunity to talk with these people and get to know these people. And I, you know, we all just kind of pick people's brains, talk about things. And there's even some good information on the internet and some discussion forums on how to do this. Now, I will tell you that a lot of people will tell you on these copper gaskets, you don't have to weld this. You can just put a scarf joint together and clamp it down. In fact, I've got some old books on working on locomotives from back in the early 1900s, and you know, most of them just say to do that. But then there are some other sources I've seen that do say to weld, and we just felt like it'd be a little bit better to weld that, so that's what we did. And there's not a lot of information on brazing copper out there. A little bit. Most people, I think, would tell you that it's probably better to use a TIG welder and weld it together, but we don't have a TIG welder, so we just went with the acetylene torch. And even though I have to admit too that I've only brazed copper a couple of times now. I practiced a little bit last night and came in and did it this morning. I'm pleased with my results, but it's not perfect. But I think it's going to be good enough for what we're doing. So we're about to the point now we're ready to put all this back together. Again, talking to some other folks who have a little more experience with doing this kind of stuff, working with copper gaskets, they do recommend that we put a kind of a sealer on here, and they recommended a copper RBT silicone type material. that's made for copper gaskets. You know, copper gaskets are still used today in automobiles for head gaskets. Usually it's a flat sheet. You know, this isn't anything that's really new, but having this wire type gasket is something that you probably wouldn't see in any kind of modern application. But we are just going to use some Permatex Ultra Copper RVT, and we'll put that on there, and hopefully that'll help make sure we get a good seal. But really, one of the main reasons we're going to use that, and one of the trickiest things about putting this whole thing back together is that there's two gaskets. There's one on the top and the bottom. And there's this machined groove that this fits into. And it's very difficult to get that thing lined up just perfect on the one that's on the bottom. When you start dropping it down, it's just hard to make sure that it's in there. You really can't see it. So by using the copper RVT, what we kind of do is we kind of use that and kind of goop it around there, and it really helps to hold that gasket in place. It's almost like we glue it in place with the RVT sealer on that bottom one in particular, to just make sure that this gasket's not moving around. And then we'll put it on and put the top one on and torque it all down, and hopefully everything will be fine. Alright, so again, we got our copper RVT sealer here, and I'm just going to put a little bead of this all the way around this right there in that machine groove. And we'll also put a bead of this around on the bottom of the head over there. David, you want to do that? Put some around over there. And we'll take our gasket and put in here. And if we are lucky, that's going to give it just enough adhesion to hold that gasket in place while we put it on. And I'm going to let that actually sit and dry for just a minute or two before we try to put it over there.
I don't know if you want in the middle, but that's in the middle.
We'll get it. We'll adjust that and get back in here.
Frame, you gotta go over.
Yep.
Break it whenever. There you go. Wanna do something, Keith?
Come on down, Chris.
Watch your fingers.
Alright. That should be it. So next, put the springs back in. You want to get some cylinder oil, and let's lube this thing up on top. It will good if we've done that. Alright, that one's front right. That's front left. Here. And that one goes right here. This is just steamed cylinder oil, and I'm just putting that on there to give it some lubrication across the top. Now we're just going to put some gasket sealer on the top gasket.
You had a dot, there's your dot right there.
Yep.
I'm gonna put this scarf back on that one. I guess it don't matter.
Doesn't matter.
It's not leaking before. Alright.
Alright. I think on this I'm just going to run another bead across the top of this gasket. Like this.
I used to make this copper stuff in a jar where you could just paint it on. A little bit different, but I wish I had that.
Now, I'm ready to put the top plate on. Yep. Maybe on the back. All right. Okay, now we're going to put the bolts back on, and we'll torque this down to what, 165?
160 is
160, 160 foot-pounds,
what we wrote down.
which is what we have in our records. I don't know where that number came from, but that's what we've always done. First thing we're going to do is just snug them all up with a regular ratchet wrench, and then we'll put the torque wrench on there, set at 160 pounds, and slowly go around and get them all good and tight. All right, we put steam on the engine here, and we're testing this out now. We're just going to put the brake on. The steam coming out of the front is just coming out of the valve. When he puts some pressure on there, you'll see that valve pop close, and hopefully we won't see any. It just pop close, or it's popping close. And going around the edge here, I'm not seeing any steam. Back here on this side, all looks good. The steam that's coming is coming from the valve up front, so I think we're okay there.
All right, we have pretty much finished this job up. Everything went back together real nice. When we fired it up, we had just a little bit of a steam leak right in here, which I didn't catch on video. But we went back in and actually retightened and retorqued all the bolts with it hot, and we had a good bit of more compression we could get with everything hot. But after we redid that, we put the brake on the engine, put some pressure on the cylinder so it had a good amount of steam pressure on it and no leaks, which is exactly what we want to. Copper gaskets are working. So this job's pretty much done. All that's left to do now is we're going to let this cool down, and then we'll come in and put that cover back on probably tomorrow, and she should be ready to run on Saturday. So there we go. Fixing the 1917 Vuclan steam locomotive. Okay.